Today we can do some numericals relating thermal properties of matter. 200 gram of ice at minus 10 degrees Celsius is added to 1 kilogram of water at 90 degrees Celsius. Find the final temperature of the mixture. Given specific heat of ice 2100 joule per kilogram degree Celsius, specific capacity of water 4186 joule per kilogram degree Celsius, latent heat of fusion of ice 3.3 into 10 raised to 5 joule per kilogram. So here 200 gram of ice is added to 1 kilogram of water at 90 degrees Celsius. Okay, so ice at minus 10 degrees Celsius is added to water at 90 degrees Celsius. So what happens when ice is added to water? Heat get transferred from water to ice. Okay, and finally ice melts and the total temperature becomes some steady temperature, let it be T, and that T degrees Celsius we have to find out. Okay, let the final temperature, so we can assume let the final temperature be T. Okay, now so when this 90 degrees Celsius water, when it is added to ice at minus 10 degrees Celsius, this water at 90 degrees Celsius lost some amount of heat, and that is gained by ice at minus 10 degrees Celsius. So what is the amount of heat gained by ice, 200 gram ice. So heat gained by ice is used for, first it is used to increasing the temperature from minus 10 degrees Celsius to 0 degrees Celsius, isn't it? When minus 10 degrees Celsius ice gets some amount of heat, first it get converted to 0 degrees Celsius ice. So heat gained by ice first in raising the temperature from minus 10 degrees Celsius to 0 degrees Celsius ice, isn't it? So when minus 10 degrees Celsius ice gets some amount of heat, first it get converted to 0 degrees Celsius ice. What is the quantity of heat required for this? Here there is change in temperature, no? So quantity of heat is given by ms delta T, since there is change in temperature. M represents the mass of ice, is equal to, mass of ice is 200 gram, isn't it? So 200 divided by 1000, convert to kilogram. S represents specific capacity of ice, that is 2100 into what is the change in temperature, minus 10 degrees Celsius and 0 degrees Celsius, change in temperature is 10. Okay, so what is the amount of heat? After simplification you will get the answer as 4200 joule. Okay, now the heat gained by ice is used for converting 0 degrees Celsius ice to 0 degrees Celsius water. That is the next step in changing the state, that quantity of heat in changing the state from 0 degrees Celsius ice to 0 degrees Celsius water. Okay, 0 degrees Celsius ice to 0 degrees Celsius water. Here change of state is taking place, so quantity of heat is given by ml, solid to liquid, no? So mlf equal mass of ice is 200 divided by 1000, convert to kilogram, into latent heat of fusion is 3.3 into 10 raised to 5, and after simplification you will get the answer as 66000 joule. Okay. Now, so first we have calculated the quantity of heat from minus 10 degrees Celsius to 0 degrees Celsius ice, then 0 degrees Celsius ice to 0 degrees Celsius water, now 0 degrees Celsius water to some T degrees Celsius water, isn't it? So in raising the temperature from 0 degrees Celsius water to T degrees Celsius. T degrees Celsius we have to calculate T degrees Celsius water. Here there is change in temperature, the quantity of heat, let it be Q3 equal to ms delta T. M is the mass, that is 200 divided by 1000 into S represents the specific capacity of water, that is 4186, and change in temperature is how much? T minus 0, that is T. and after simplification you will get the answer as 837.2 T. T we have to calculate, T joule. Clear? So this is the method, or this is the heat gained by 200 gram ice. The total heat gained by ice, first from converting minus 10 degrees Celsius to 0 degrees Celsius, then 0 degrees Celsius ice to 0 degrees Celsius water, then 0 degrees Celsius water to finally T degrees Celsius water. And heat lost by, what is the amount of heat lost by 1 kilogram of water at 90 degrees Celsius? 1 kilogram of water at 90 degrees Celsius, so that its final temperature becomes, what is its final temperature? Becomes T degrees Celsius, so that its final temperature becomes T. Okay, because this 1 kilogram of water at 90 degrees Celsius lost the quantity of heat and it is gained by this ice. Okay, so heat gained by 1 kilogram of water in changing the temperature from 90 degrees Celsius to T degrees Celsius. So that quantity of heat, let it be Q. That quantity of heat is given by ms delta T, because change in temperature taking place. M represents the mass of water, which is 1 kilogram, into specific capacity of water 4186, into what is the change in temperature? 90 minus T. Temperature always decreases, no? So 90 minus T. Clear? And after simplification you will get, it is 4186 into 90 is 376,740 minus 4186 T. This T we have to find out. So this quantity of heat is applied to which one? Ice. Okay, so heat lost by 1 kilogram of water is given to, or it is gained by 200 gram of ice. So we can write, according to the principle of calorimetry, this material loses the amount of heat and this ice gains the quantity of heat. So from principle of calorimetry, heat loss is equal to heat gained. Clear? So we can write heat loss, that is Q equal heat gained. What are the values of heat gain? Q1 plus, here Q1 plus, Q2 plus, Q3. Clear? So Q equal to Q1 plus, Q2 plus, Q3. You can substitute. What is the value of Q? This one, 376,740 minus 4186 T, equal to, what is the value of Q1? 4200, plus what is the value of Q2? Q2 is equal to 66,000, plus what is the value of Q3? 837.2 T. Okay, now we can simplify. So after simplification you get 66,000 plus 4,200 is 70,200, and it can be taken to the left side, and after simplification you will get 306540 equal to, we can add these two terms containing T, and that is 5023.2 temperature T, and T is equal to, we can divide 306540 divided by 5023.2, and the simplified value is 61 degree Celsius. Okay, so when 90 degrees Celsius loses some amount of heat, it becomes 61 degree Celsius. So final steady temperature is 61 degree Celsius. Now second question, when 0.15 kilogram of ice at 0 degrees Celsius is mixed with 0.3 kilogram of water at 50 degrees Celsius in a container, the resulting temperature is 6.7 degrees Celsius. Find the latent heat of fusion of ice. Given specific heat of water 4186 joule per kilogram degree Celsius. This is also based on the principle of calorimetry. So when 1.15 kilogram of ice is mixed with 0.3 kilogram of water at 50 degrees Celsius, we know that water lost some amount of heat and it is gained by ice, isn't it? So what is the amount of heat? Amount of heat lost by 0.3 kilogram of water, so that its temperature changes from 50 to 6.7, so that its temperature changes from so that its temperature changes from 50 degrees Celsius to 6.7 degrees Celsius. Let that quantity of heat, let it be Q1. Q1 equal to, here change in temperature take place, no? So which formula? Ms delta T. M represents as the mass of water, that is how much is the mass of water? 0.3 into specific capacity 0.3. 0.3 into specific capacity of water 4186 into what is the change in temperature? 50 minus 6.7. Okay, and after simplification you will get the answer as 5437.6.15, this much joule. Okay, and this quantity of heat is absorbed by 0.15 kilogram of ice, isn't it? So amount of heat gained by 0.15 kilogram of ice. Okay, 0.15 kilogram of ice. First one, when 0.15 kilogram of ice gains some amount of heat, it is at 0 degrees Celsius. No? 0.15 kilogram of ice at 0 degrees Celsius. When it absorbs some amount of heat, first it becomes 0 degrees Celsius water. Ice becomes 0 degrees Celsius water, isn't it? So amount of heat gained by 0.15 kilogram ice in converting 0 degrees Celsius ice to 0 degrees Celsius water. Okay, 0 degrees Celsius ice get converted to 0 degrees Celsius water. What is the amount of heat? Let it be Q2. That quantity of heat is ice to water. So quantity of heat is ml. F. M is what is the mass? 0.15. Into latent heat of fusion we have to find out. LF we have to find out. Okay children. Now second one, after converting 0 degrees Celsius ice to 0 degrees Celsius water, remaining quantity of heat is used for changing the temperature from 0 degrees Celsius water to what is the final 6.7 degrees Celsius water. So quantity of heat required in converting 0 degrees Celsius water to 6.7 degrees Celsius water. Here change in temperature is there. So quantity of let it be Q3 equals Ms delta T, change in temperature. M represents the mass of water which is given by 0.15. Specific capacity 4186. What is the change in temperature? 6.7 minus 0. So its answer is 4206.93 joule. Okay, so heat lost. According to the principle of calorimetry, heat lost is equal to heat gained. Okay, so heat lost is equal to heat gained. So from principle of calorimetry, heat lost is equal to heat gained. So heat lost is Q1 equal to what are the values of heat gained? Q2 plus Q3, isn't it? Q2 plus Q3. So Q1 equal to Q2 plus Q3. We can substitute Q1 is 5437.6.14 equal to Q2 is 0.15 latent heat of fusion plus Q3 is 4206.93. And if this 4206.93 can be taken to the left side, 54376.14 minus 4206.93 is equal to 0.15 latent heat of fusion. After simplification, LF is equal to, what is the value of LF? 3.34 into 10 raised to 5 joule per kilogram. Okay, after simplification, we will get the answer as 3.34 into 10 raised to 5 joule per kilogram. Now, third question, how much heat energy is absorbed when 50 gram of ice melts at 0 degrees Celsius? Latent heat of fusion of ice is 3.35 into 10 raised to 5 joule per kilogram. So, amount of heat, the quantity of heat, energy absorbed during melting of ice. So, energy, heat energy absorbed during melting of ice is Melting of ice means ice get converted to water at 0 degrees Celsius. So what is the formula? M into LF. Okay, since there is a change of state taking place, so quantity of heat is given by mLF. What is M given? 50 gram. You can convert to kilogram. 50 into divided by 1000 into latent heat of fusion is 3.35 into 10 raised to 5 joule per kilogram, and after simplification you will get 1.675 into 10 raised to 4 joule. Okay, this is a direct question. A copper block of mass 2.5 kilogram is heated in a furnace to a temperature of 500 degrees Celsius and then placed in a large ice block. What is the maximum amount of ice that can melt? Specific heat of copper 0.39 joule per gram degree Celsius. Latent heat of fusion of ice 335 joule per gram. Okay, here specific heat and latent heat are expressed in gram. Okay, so here when a copper block of 2.5 kilogram, it is heated in a furnace to a temperature of 500 degrees Celsius. So what is the temperature of the copper block? 500 degrees Celsius. It is placed in a large ice block. When it is placed on a large ice block, what happens? Ice block melt. So heat is absorbed by the ice block, and who loses the amount of heat? Copper block loses the amount of heat. So that is also according to the principle of calorimetry. So we can do like this: heat lost by copper block is equal to heat gained by ice, isn't it? So what is the amount of heat lost by copper? So when mass of copper is 2.5 kilogram, its initial temperature is 500 degrees Celsius. Okay, when it is placed on ice block, it melts. So what is the amount of energy lost by copper block? It is given by M/S delta T. M represents the mass of copper, S represents the specific capacity of copper, and delta T represents the temperature change. Is equal to what is the heat gained by ice? When ice gains amount of heat, it gets melt. Okay, so M into LF. Clear, children? Here M represents the mass of the copper. We can substitute 2.5 into 2.5 kilogram, no? So we have to convert to gram because all the specific heats and the latent heat are expressed in gram. So here 2.5 into 10 raised to 3 kilogram to gram. Into specific heat capacity of copper is 0.39. What is the temperature change? 500 degrees Celsius equal to mass of ice we have to calculate into latent heat of fusion is 335. We can simplify, and after simplification get mass of ice is equal to 2.5 into 10 raised to 3 into 0.39 into 500 divided by 335, and its answer is 1455.2 gram, or you can write 1.455 kilogram. Okay, children. A 10 kilowatt drilling machine is used to drill bore in a small aluminium block of mass 8 kilogram. How much is the rise in temperature of the block in 2.5 minutes, assuming 50% of power is used up in heating the machine itself or lost to the surrounding? Specific heat of aluminum is 0.91 into 10 raised to 3 joule per kilogram degree Celsius. Okay, so 100 kilowatt drilling per kilowatt means it is a unit of power. Okay, so power is equal to 10 kilowatt. Convert kilo to kilowatt to watt, that means 10 into 10 raised to 3 watt, that is given. So temperature time T is equal to 2.5 minutes. You can convert to second, so that is 2.5 into 60. 2.5 into 60, that is equal to 150 seconds. 50% of power is used up in heating the machine or lost to the surrounding. So only 50% of the power is used for heating the machine. 50% of power is lost. Okay. From this we can find out the energy. Energy is equal to power into time. We have power equal to energy by time, or work divided by time. So energy is equal to power into time. So power means 10 into 10 raised to 3 into time is 150. So it is 1.5 into 10 raised to 6 joules. Okay. Out of 1.5 into 10 raised to 6 joule, only 50% is used for heating purpose. Okay, and remaining 50% is lost to the surrounding. Say amount absorbed by the block. Say amount of energy absorbed by the aluminium block is 50% of this one. Okay, remaining 50% is lost to the surrounding. So amount of energy absorbed by the aluminium block is 50% of this total energy, 1.5 into 10 raised to 6. 50% means 50 by 100. Okay, into 1.5 into 10 raised to 6. And it is equal to 0.75 into 10 raised to 6 joules. So the amount of energy absorbed by the aluminium block is 0.75 into 10 raised to 6 joules. So amount of energy absorbed by the aluminium block is used for changing the temperature. Okay, so here 0.75 into 10 raised to 6 joule of amount of energy is given to the aluminium block so that its temperature changes. So its mass is ms delta T, we can substitute. We have to find out this change in temperature, isn't it? So we can write 0.75 into 10 raised to 6 is equal to mass of aluminium. What is the mass of aluminium? 8. Specific heat capacity of aluminium is given 0.91 into 10 raised to 3. We have to find out the change in temperature. No? How much is the rise in temperature? So delta T. We can simplify delta T equal to 0.75 into 10 raised to 6 divided by 8 into 0.91 into 10 raised to 3, and after simplification you will get 103 degree Celsius. So this is the change in temperature. Okay children.